Okay, good morning, dear students. This morning, we will learn about a new topic, subgroups. But prior to discussing subgroups with you, I'd like to discuss first some of the common mistakes in your midterm examination. So I took note of several items in which most of you have committed mistakes, even for part 2 of the midterm examination, that we will discuss before we proceed to the next topic, which is subgroups. Okay, but prior to discussing with you some of the common mistakes, let me first, discuss or explain what a Cayley table is. Although I have mentioned this in the past, Cayley table, this is in honor of the mathematician Arthur Cayley. Okay, so in your midterm examinations, I also have included some items involving the Cayley table. If you could remember an item G, or an item which shows a set G consisting of the elements 2, 4, 6 under multiplication modulo 10, and there is also an item there which shows a binary operation, binary operation asterisk over the set 1, 2, 3, 4, 5. And in part 2 of your examination, I also gave a table. Okay? So, what are some of the properties of the Cayley table? But prior to listing down the properties, let's first prepare a Cayley table for set S. Okay, let set S be the set whose elements are 1, I, negative 1, and I. Okay? Take note that your I is the square root of negative 1. Okay? The square root of negative 1. Which means that I squared, what is it equal to? I squared is equal to, I is referring to the complex number I. Okay? I squared, when you square this, it will be negative 1. Okay? So, I here is your complex number. Okay? I plus 0, or I, simply I. And the operation defined on set S, let the operation be multiplication. Okay? Let's prepare a table, okay? A table for set S, okay, under the operation multiplication. So there are how many elements of set S? There are 4 elements. Okay, let's prepare the Cayley table for set S. Okay, is my table visible? Or we can make it a little bigger. Let me erase first, and then let's make it bigger, so that those who are using their mobile phones can also see it. Because there are some of you, or many of you, are using cell phones, not laptops. Okay, so let me make the table bigger. Okay, and the operation is multiplication. Okay, let's fill out the table. Filling out the table with the results after multiplying every element. Okay, 1, I, negative 1, and sorry, this should be negative I, negative I. 1 positive, 1 negative. So, we have here negative, or let me use black to distinguish it from the table. Sige, black tayo. Okay, so 1, and then I, negative 1, and negative I. 1, I, negative 1, and negative I. Okay, let's multiply. Fill out the table. Okay, let's multiply the first row and the first column. 1 times 1, what is it equal to? 1 times 1 is equal to 1. Okay, and all of this we simply copy because anyway multiplication by 1 gives the element itself. So I, negative 1, and negative I. Okay, we proceed to the next. In like manner, the first row or the second row rather could be filled out right away because this is anyway multiplying by 1. 1 times I is I, negative 1 times 1 is negative 1, and this will be negative I. Okay, next we proceed to the next, third column. Third column, what is I times I? I times I, okay, take note that I times I, which is I squared, is negative 1. Okay, moving on to the next, negative 1 times I is negative I. Okay, negative I. Next, negative I times I is negative of negative 1 is positive 1. Okay? Next, we proceed to the next. I times negative 1 is negative I. Okay? Next, negative 1 times negative 1 is positive 1. Okay? Next, negative I times negative 1 is positive I. Okay? Positive I. And then, last column, negative 1 times negative I is equal to positive I. Kita ka? Positive I. Okay? Next, negative 1. We skipped one cell. Okay, may I erase this first? What should this be? Okay, I times negative I, negative of negative 1 is positive 1. Okay, positive 1. Okay, negative I, next, negative I times negative 1 times negative I should be positive I. Okay, and finally, negative I times negative I. Paano naging 1 yun? Sige, mamaya. Negative I times negative I is positive I squared. Okay, take note of this. Let me highlight. Okay, those who came in late, ito. Okay, from your I is the square root of negative 1. Remember the imaginary number? I is equal to the square root of negative 1. Okay, so you have here then, is that clear? Okay, negative I times negative I, let me write here so that those who came in late can follow. Ito, let me write it here. Negative I times negative I is equal to positive, yes, I squared. However, what did we say? What did we say about I squared? Naintindihan nyo na? Okay, so I squared is negative 1. So this is equal to negative 1. Okay, so what shall I write here? Negative 1. Any other question? Okay. What's your question? Ito. Okay. I think your question is this. I times negative I. Okay, let me write that also. Let this be, A na lang. A. And then B, if we have, where is that? I times negative I, what will this be? I times negative I is negative I squared. But what did we say about I squared? Okay, I squared is equal to negative 1. Okay, so this becomes the negative of negative 1, which is positive 1. Correct? Okay, there you have it, positive 1. That's from I times negative I. I times negative I is equal to positive 1. Now, I took note of some of your common mistakes in the examination. We begin with 1, okay? 1 that involves a Cayley table. There is one item in your examination in which, okay, number 1, let's say this is number 1, the group consisting of the elements 2, 4, 6, and 8. Okay, under multiplication modulo 10. Okay? Multiplication modulo 10, and these are the elements. So, preparing a table for, or in fact, the table is already provided in the exam. Meron na siya eh. Okay, the table is already there. All you have to do is to inspect and look for the identity and the inverse, because that is what the question is asking for. In your examination, it asks for the identity element. So the operation is, although yan, multiplication modulo 10, 2, 4, 6, 8. 2, 4, 6, and 8. Then simply multiply 2 times 2, that's 4. Okay, 4 times 2, 8. 6 times 2, 12, modulo 10, 2. Okay, 8 times 2, 16, modulo 10, 6. 2 times 4 is 8. 4 times 4, 16, modulo 10, 6. Correct? Next, 6 times 4 is 24, modulo 4, 4. 8 times 4, 32, modulo 10, 2. Okay? 2 times 6, modulo 10 is 2. 4 times 6 is 4 because of 24. 6 times 6 is 36, modulo 10 is 6. 6 times 8 is 48, modulo 10 is 8. Obvious na yung identity element, nakikita na. Okay? 2 times 8 is 6. 16, modulo 10. 6 times 8, 4 times 8 is 32. So 2, 6 times 8, 48. 8 times 8 is 64. Okay, the problem asks for identity element. Find the identity element. Okay, what is the identity element? Identity element. Maraming di nakakuha dito. What is the identity element? Look at what we did in the previous. Look at this. Look, all entries equal to this. These entries are equal to this. So going back. Compare, I want you to compare or pay attention to the third row. Third row and third column. See, look at this. 2, 4, 6, 8, 2, 4, 6, 8. Okay? And then one thing more. 2, 4, 6, 8, 2, 4, 6, 8. Which means that the identity element must be 6. Okay. So here, the identity element is 6. Okay, E is equal to 6. The identity element is 6. So, follow-up question, what are the inverses of each element? Okay, so what is 2 inverse? What is 4 inverse? What is 6 inverse? And what is 8 inverse? Okay, what did we say? The technique is, per row, look for the identity element. Diba? The identity element is 6, which means that the inverse of 2 must be 8. Okay, so 2 inverse is 8. Next, how about 4 inverse? Okay, 4 inverse, 4. Okay, our identity element 6. What is multiplied to 4 to get 6? There, 4. Okay, so 4 inverse is 4. Next, 6 inverse. What is the inverse of 6? Okay, hanapin sa identity element 6. What was multiplied to it? Okay, 6. Inverse of 6 is 6. And finally, inverse of 8? 8. What must be multiplied to 8 to get 6? It's 2. Okay, so 2. Okay, is this a group? Yes. In fact, in the question stem, it says it's a group, which means every element have inverses and there is an identity element, and that identity element is 6. This, in fact, is an example of a subgroup. Okay? Sorry, it's a group rather, I should say. Group. Okay? I hope this is clear now. So we could move on to the next item. So common mistake. Yeah. Number 2. Okay, common mistake. Number 2. We have set Z, your set of integers, and a binary operation star defined on the set of integers such that A star B is equal to A plus B plus 1. Okay, A plus B plus 1. So that's how the operation asterisk is defined. A star B is equal to the first and this plus the second plus 1. The sum plus 1, that's the meaning of star. The sum of the two numbers plus 1, such that the two numbers are elements of the set of integers, Z yan. What's the question all about? The question asks for, in this problem, it asks for identity. Find the identity element. Okay, find the identity element. By the identity element, we mean an element such that when we multiply it, okay, A times or star, this identity element should yield, when we operate A with the identity element E, just a representation, it should give, okay, A itself. Okay? A din dapat kung identity si E. So, basing from the definition, work on the left side of the equation. What did we say? By definition, A star B is A plus B plus 1. So, do it here. A star E is simply A plus E plus 1. Okay? So, let me write that here. A plus E plus 1 because that's the definition of the operation star. Okay? Get the sum plus 1. So, get the sum A plus E plus 1 equals, okay, equals A. What are we looking for? Take note that this asks for the identity element. So, we have to find E. Okay, so let's simplify further. Take note that A and A will cross out because if we subtract A from both sides, this will now be eliminated. Yes? And what is left? What is left? We are now left with E equal to negative 1. Okay, that's it. The identity element is negative 1. Okay, identity element is negative 1. So, what about if there is a follow-up question? Find the inverse. Okay, inverse naman, okay, let me put it on this side. Okay, how about the inverse of A? So, this is what we are going to do next. Look for the inverse of A. Okay, by definition, when we speak of inverse, okay, A times its inverse, may we represent it as a raised to negative 1? Okay? A times its inverse should yield the identity element. Okay? It should give the identity element. However, we already found this to be negative 1 from our previous step. Okay? So we found this to be negative 1 so that this could be simplified to A star A inverse equal to negative 1. Okay, again, by definition, what is A star A inverse? Go back to the definition of, the definition of the operation star. Okay, it's defined as, again, A plus A inverse plus 1 equals negative 1. Okay? A plus A inverse plus 1 equals negative 1. Okay? By this definition, the sum of the 2 plus 1. So, the sum of the 2, that's it, plus 1 equals negative 1. So, we now proceed to looking for A raised to negative 1. So, what will this be? A raised to negative 1 equals, what happens to this? This one will be, negative 2 minus A. Okay, so this is the answer. So the inverse of A is negative 2 minus A. Now let's check whether this really is the inverse of A. Okay, let me have it here. Okay. A, again, by definition, A star B is equal to A plus B plus 1. What did we find out? That E is equal to negative 1 and that A inverse is equal to negative 2 minus A. Okay, i-check natin. A star, okay, element should be A. It should be. Otherwise, then E fails to be an identity element. Okay, so let's see. A star, what did we find as E? Negative 1 should be equal to A. Kung hindi, mali. Okay? So again, by definition of the operation star, star is defined as A plus 1 minus 1. Okay? So, A plus, negative 1 plus 1. Is it equal to A? This will cancel out, yes, because this will be 0. A is equal to A. Correct. Identity element really is equal to negative 1. How about this? Okay, checking on the inverse. So, let's check on the inverse. Okay, so by inverse, we mean when A is multiplied to its inverse, the result should be E, the identity element. So, when A is multiplied to A inverse, it should be equal to negative 1. But what is this? We found it to be this. Okay, negative 2 minus A. So, A, star, negative 2 minus A, is it equal to negative 1? Okay, let's see. Again, using the definition of star, this plus 1. Okay, tingnan natin. So, A plus negative 2 minus A plus 1. Will it be equal to negative 1? Okay, obviously, they are equal. A with negative A will strike out, and negative 2 plus 1 is equal to negative 1. Correct? Negative 1 equals negative 1. Did you understand that? Okay, so this is how to look for inverses and identity element. Remember that identity multiplied to an element yields the element itself. And element times its inverse, element times its inverse equals the identity element. Okay? Next. Parang meron pang isang ganun. Okay. Here's another problem. Problem number 3. You know, from until the finals, we will be talking about properties. Okay? When we get to rings, when we get to homomorphism, isomorphisms, Lagrange theorem, Fawcett, we will always talk about properties. Okay, so number 3. Star is a binary operation on set Z. Okay? Such that set Z such that A star B is equal to A plus B plus AB. Okay, so this is the meaning of the operation star. What does it mean? A star B means get the sum of the two numbers plus their product. The sum plus their product. Get the sum of the two, add it to their product, and that's A star B. So, for instance, if you have, okay, example lang, 3 star 2, what will this be? 3 star 2 means 3 plus 2 plus 3 times 2. That's the meaning, which is equal to 5 plus 6 or 11. Okay, but that's not the question. What is it asking for? Okay, suppose we have 3 star 4 star x is equal to negative 1. We are to look for x, find x. Okay? So this appears again in your examination. 3 times 4, 3 star 4, the quantity, 3 star 4 star x is equal to negative 1. Find the x. Okay, so let's apply the definition. So from the definition, yan, add the 2 plus the product. Okay, so let's first simplify that in the parenthesis. What will be 3 star 4? Add the 2, 3 plus 4, that is 7. Let's do it step by step then. 7 plus, add it to their product. 3 times 4 is 12. I hope that is clear. 7 came from 3 plus 4. Ito A plus B. A plus B muna. 3 plus 4, 7 plus AB product. Okay, 12 came from 3 times 4. Okay, and close it in a pair of parentheses. Star x equals negative 1. Okay, and this is 19 star x equal to negative 1. Okay, now operate on 19 and x. Using the definition once again, sum plus product. So sum is 19 plus x. Okay? Plus their product is 19x. Again, 19 plus x, that's a plus b. Plus ab, 19x. Okay? Equals negative 1. Combining like terms, x and 19x is 20x. Okay? Equals negative 20. So what is x then? X is equal to negative 1. Okay, that's it. X is equal to negative 1. Is this clear now? So we could move on to the next. Next. There is another item on binary operation, 2 binary operations, and it has to do with distributivity. Okay? Distributive property. Wait 1 minute. Okay, number 4. Let's name this question number 4. Let star be defined as A star B this time is equal to A plus B, A plus B. This time it's not plus but minus AB. A plus B, A plus B minus AB. And the question is star commutative? Is star associative? Okay, that's the question. Is star commutative? Is star associative? Now, let's check on commutativity in general. So, first, A star B, is it equal to B star A? Kaya ano bang definition ni star? Star says sum minus product. Their sum minus their product. So, A star B is simply, A star B is simply AB, sum, sorry, it's a sum. Sum muna. A plus B minus AB. Will it be equal to this? Okay, let's see. Their sum, B plus A minus BA. Are they equal? Okay, A plus B minus AB, are they equal? Now, you know that the ordinary addition or addition in the set of real numbers is commutative. So, by that property, we can rewrite this as A plus B. We can rewrite this as A plus B. Reason? Reason? Addition is commutative in the set of real numbers. Or commutativity plus is commutative. Take note, we're dealing with whole numbers. Commutative in R. R, your set of real numbers. So I could rewrite it in this manner. In like manner, minus. Okay, minus B and A are real numbers. And you know very well that multiplication is commutative in the set of real numbers. So I could rewrite this also as A, B. So the left and the right are now equal. So commutativity is satisfied. Commutative siya. Okay? Commutative. So ito, yes, it's commutative. Kasi ang options natin, commutative, associative, commutative, and associative, not commutative, not associative in the multiple choice. So you can verify with one example is, okay, let's verify, is 3 star 4 equal to 4 star 3? Okay, again, by definition, get the sum minus the product. Sum minus the product, so 3 plus 4, that will be 7 minus 12. Is it equal to 4 plus 3, 7 minus 12? Obviously, they are equal. Negative 5 equals negative 5. Okay. Next, how about associativity? How do we check on associativity? So we're done with commutativity. Correct. Associativity, let's see. Okay. Is A star B star C equal to A star B star C? Pareho ba? Okay, let's see. Okay, let's operate on A star B muna. By definition, it's A plus B minus AB. Okay, star C. How about here? A star, operate on B star C. This will be the quantity B plus C minus BC. B plus C minus BC. Okay, now apply. Apply the formula once again, or the definition. The sum minus the product. Okay, the sum minus the product. The sum is A plus B minus AB plus C minus the product. A plus B minus AB times C. Pareho ba? Okay, let's see. The sum A plus the quantity B plus C minus BC minus, okay, A times B plus C minus BC. Wait, the space is not sufficient. Let's make it smaller. Minus A times B plus C minus BC. And see whether the left and the right side will be equal. So, A plus B minus AB plus C minus A minus B. Sorry, minus AC. That should be minus AC. Because this is multiplied to. This is multiplied to each term inside. So, minus, what should this be? Minus AC minus BC plus ABC. Is it equal to this? A plus B plus C, okay, minus BC minus AB minus BC plus ABC. You can check. May A plus B plus C. Okay, tama. Look at this. Let me underscore. Okay, let me underline. A plus B plus C. Yun. A plus B plus C. Pareho. And then minus AC. Meron bang minus AC? Merong plus ABC plus ABC. Okay, may BC. May BC. Minus, I failed to include here AC. Wait. Okay. Kulang tayo dito. Let me just write it properly. So, minus BC. Let's check first. A, correct, plus B plus C minus BC. Then, minus AB minus AC plus ABC. Are they exactly equal, left and right? ABC, meron siyang ABC. May BC, merong BC. May AB, may AB, minus AC, minus AC. Yes! Okay, so, star is also associative. So, answer is commutative and associative. It's both commutative and associative. Okay? Commutative and at the same time associative. Next. Okay, part 2 of the exam. Okay, part 2 of the examination, the table is provided. The table is given and the table looks like this. The operation is a star. Only one of you got the correct answer here. All the rest wrong. The operation is star and the elements of the set are E and O. Okay, so E and O. In fact, E here stands for even. Okay, and O here stands for odd. And star here is the operation multiplication. So I'm revealing it now. Okay, the operation is multiplication. When you multiply an even number with an even number, the result is even. When you multiply an odd number with an even number, it's even. When you multiply an even number with an odd number, it's even. And when you multiply, add, and add, that's the only time you get an odd number. Question number 1. Okay, because this asks for proving whether the set under the operation star is a group. Okay, is it a group? Is S a group with respect to WRT, okay? With respect to star? That's the question. So we look into each of the properties. I, closure. Is closure property satisfied? Okay, is closure property satisfied? Yes, look at the entries. Okay, the entries in the table. All elements of the set. E and O, E and O. No foreign element. So, answer here, yes. It is closed. Closure property is satisfied. Next, number 2. Okay, associativity. Associative ba? You can verify with 1. So, E star O star E, is it equal to E star the quantity O star E? Okay, what is E star O? Okay, E star O is E. Okay, so E star E. How about here? Question mark first because we're still in the process of checking. Star O circle O star E. What is O star E? O star E is E. Okay, E. Next. O yan na o. Pareho na siya. E star E is equal to E equal to E. Okay. Associativity is satisfied? Yes. Next, number 3. Okay, number 3. 1, 2, 3. What is the identity element? Dito kayo nagkagulo. Isa lang nakakuha sa inyo sa buong klase. The identity element. What is the identity element? Okay, identity element, I'd like to bring your attention to this. Tsaka yan. Okay, hindi E. Okay, so isa lang nakakuha sa inyo. The identity element is O, it's not E. The identity element is O. And so, number 4, inverses of each element. Of each element. What is E inverse? And what is O inverse? Okay, now looking for E inverse, walang entry na O along this row. Wala. Okay? So, E inverse does not exist. DNE. Okay? E inverse does not exist. How about O inverse? Si O lang ang meron. Okay? O, this is the identity element. Sabi ko, hanapin nyo si identity element, si O. Ano yun? Okay, O. Its inverse is O. And therefore, which property is not satisfied by the set? Okay? Under the operation defined on it. Ito, the fourth property is not satisfied. Okay? Since one of the elements does not have an inverse, and that is E, then we can say property number 4 is not satisfied. Therefore, okay, S under the operation star is not a group. Yan ang rason. Although all of you answered it's not a group, but your reason is wrong. Okay? Wrong reason. This is the correct answer. Inverse of each element. There is one element without an inverse, and that element is E. E inverse does not exist. So that disqualifies S to be a group. Hindi siya group. Okay? Not all elements have inverses. Next. One last. What time is it with you? 12:15. Okay, next. On surjective functions, f of x is equal to x plus 1 on the set of counting numbers or n or natural numbers. Counting numbers or your n. Is it onto? That's the question. Is it onto? F of x is equal to x plus 1 on the set of counting numbers. Is it onto? When is it onto? When is it onto? Onto or surjective? Yes? If it is surjective, correct? Onto or surjective? Can you recall? Surjective. Anyone who can describe a surjective function? What did we say about a surjective function? When is it surjective? Or when is it onto? Anybody? Ayan, surjective nga. Okay? Onto function or surjective. Anong sabi natin? When the range and the codomain are equal. Sige. N to N ito the function f is defined on the set of counting numbers to the set of counting numbers. Now I'm asking you. The range and the codomain are equal. So this is our codomain. Okay? The range and the codomain are equal. Looking at the given, x plus 1. X plus 1. What are your counting numbers, by the way? Your counting numbers are, x could be 1, yes? If x is 1, what is the function value? It's 2 na agad, correct? It's 2 right away. X equal to 2, then the function value is 3. When x is 3, the function value is 4. Question, will there ever be a function value or will there ever be an x value that will give this function value? Take note of your domain. Your domain is n. Counting numbers. Is there an x value? Okay? Is there an x value that will give a function value of 1? Is there? Meron ba? Is there a value of x that will give 1 as the function value? Wala. Okay? Because we cannot take 0. Can x be 0? Only when x is 0, the function value, okay, the function value is 1. However, is this part of the domain? Hindi. Okay? Remember, it's defined on the set of counting. Kaya, ang answer dito ay false. Hindi siya onto. Okay? It's not onto. Okay? It's not onto because you can never get 1. Okay? You will never... There is no x value, rather, there is no x value that will give a function value of 1. And 1 is an element of your, okay, counting numbers. And what did we say? The range and the codomain should be equal. The range and the codomain should be equal. And your n includes positive 1. But function value will never be 1. Because our domain is n, counting numbers, n to n. Okay? I hope this is clear also. Next. Okay. For subgroup, last for this morning, it's 12:21. I'll just give you the definition of a subgroup and give you one example before we end the session. So, subgroup by definition, from the word itself, sub, group. So, from a group, we form, okay, a smaller set which satisfies all the properties of a group, and therefore we call it a subgroup. So, by definition, a subgroup of group G is a subset of G which forms a group with respect to the operation in G. Okay, examples. Okay, number 1, the set of even integers forms a group or subgroup, I should say, of the additive group of the set of integers. Okay? So the set of integers is a group under addition because it satisfies closure property, it satisfies associativity, there is an identity element which is 1 and 1 is an element of Z, and all elements have additive inverses. Okay? Now, the set of integers includes your even numbers. Yes, so it's a subset. Your set of even numbers is a subset. Okay? A subset of, okay? Subset, what did I say? Additive group. Identity element is 0, I should say. Okay, so for your set of integers, it satisfies, okay, the 4 properties. We are talking of addition, additive group. So closure property is satisfied, associativity is satisfied, identity element is 0, okay? 0 is an integer, and inverses of every element exists. Okay, so that's Z with respect to the operation addition. But a subgroup of Z is your Z sub E. Set of integers even, Z sub E. This is a group. We said a while ago, this is a group. This Z sub E, set of even integers with respect to the operation addition, is a subgroup of G. So subgroup siya because it satisfies all the properties. When we add any two even numbers, the result is an even number. So that's satisfying closure property. For example, 2 plus 0 is 2. 0 and 2 are both even. 2 plus 4 is 6. 6 is even. 2 and 4 are even. Closure property is satisfied. Then associativity, and then existence of an inverse, 0 is the additive inverse. 0 is the additive identity, I should say. Identity element with respect to addition, and 0 is an even number, and every even number has inverses. Let me write that as well as I could. Okay, closed. 2, addition is associative. 3, the identity element with respect to addition is 0. And number 4, all elements have inverses. All elements have inverses. So this one forms a subgroup of the set of integers. So it's a subgroup. Okay. Remember your set of rotations on the plane. Okay, your set G consisting of RO, R1, R2, R3, X, Y, D1, and D2. In fact, you can find a subgroup there. Okay, so if you still have the table with you, okay, if you check on the table, let me check if I still have that. Your RO, R sub 0, R sub 1, R sub 2. Remember these rotations on the plane, motions of the square on the plane, or set of symmetries of a square. Okay, counterclockwise rotation. RO is no motion at all. R1 is counterclockwise rotation by 90 degrees. R2 is counterclockwise by 180. R3 is counterclockwise rotation by 270. And then recall that RO is our identity element before, so entries here are exactly the same. R2, R3, In like manner, first row R1, R2, R3, and this is in fact R2, R3, R sub 0. You can verify if you still have it with you. Okay, R2, R3, R, saan na to? R sub 0, R sub 1, R sub 0, R sub 1, and this is R sub 2. And the other parts of your table for X, Y, and D1 and D2, but we just want a subgroup. Okay, this is a subgroup of G. Okay, closure property is satisfied. It is closed. Okay, number 2, it is, okay, the operation is circle, is associative. By the way, when we speak of closure, we mean the set, okay? When we speak of closure, the set, when we get any two members of the set, operate it and by whatever the operation defined on that set is, and the result is a member of the set, then that's closure. When we speak about commutativity and associativity, we mean the operation, okay? So commutativity and associativity has to do with the operation. So why we say circle is associative. Then number 3, identity element. Is there an identity element? Yes, and we said before that the identity element here is R sub O. So siya R sub O. Okay, and number 4, inverses. Yes, every element has an inverse. R sub 0 inverse is R sub 0. R sub 1 inverse is equal to R sub 3. R sub 2 inverse is R sub 2. And R sub 3 inverse is R sub 1. Okay? Kaya subgroup siya. Therefore, this is a subgroup of G. Okay? We end up here. We will continue next meeting. Are there questions at this point? None. Okay, one last din. Naalala ko. The last part of your part 2 or part 2 of your examination, you are given the sum of two matrices and the difference of two matrices, and you find the matrix X and matrix Y. Okay, this is by using your simultaneous equations. Okay, so if this is X plus Y, X minus Y, you can add. Remember that you can add matrices. It's defined. So if I add the two, what will I get? X plus X, that will give me 2X. Okay, and then Y minus Y will be 0. So what will I do? What is the definition of matrix addition? Add correspondingly the entries. So 1 plus 3, this is not the exact, okay, this is not exactly what is given in your exam, but just for an example, so that you will know the process. Yan, 1 plus 3, that gives a sum of 4. We are adding. What are we doing? We are adding the two equations. Okay, we're dealing with equations here. Equal sign, equal sign. Equal sign, equal sign. Okay, so equations, we're talking of equations. So we can use addition property of equality. Or addition, yes. Addition property of equality. Add the two, you will end up with 2 plus 4, that gives 6. Okay, next, 3 plus 5, that gives 8. And then 4 plus 6, that gives 10. Okay. And then how do you get rid of 2? Divide. Yes. So X will simply be 1/2 of all the terms inside. 4, 6, 8, 10. And that would give, okay, 1/2 of 4 is 2, 4, 3, 5. That's X. And how will you solve for y? Use any of the two equations. Okay, solve for y and then solve for y. So if this is y, then use either equation 1 or equation 2. Using equation number 1, x plus y is equal to 1, 2, 3, 4. And what did we find as x value? So, x value is yan, 2, 4, 3, 5 plus y equal to, kinoropya ka mo. Okay? 1, 2, 3, 4. Halata kasi pareho ang mali nyo. Okay, y is equal to 1, 2, 3, 4 minus all of this. 2, 4, 3, 5. Y will be as simple as that. Subtract every corresponding element. So what will this be? Negative 1, negative 1, negative 1, negative 1. Okay, that's it. 1 minus 2, negative 1. 2 minus 3, 2 minus 3, negative 1. 3 minus 4, negative 1. And 4 minus 5 is negative 1. This is minus. Okay? So we end up here. We will continue with cyclic groups, cyclic subgroups, okay, cyclic groups next meeting, and more examples on subgroups. Okay, and please review your properties. Okay? Distributive property, multiplicative inverse, additive inverse, associativity, grouping, commutativity, places. May mga nagkamali doon. Okay? And your DPMA, distributive property of multiplication over addition. Okay, so we end up here. If there are no questions, then we could end up the session. I'm not giving any assignments yet. Okay. For next meeting na lang, to give me time to check or go over your previous assignments also. Okay? Bye everyone!